Hello class, welcome back to my page. This is Listowall, and today we are going to treat a topic in practical geography. Practical geography. We are going to treat a topic that is interesting and it is widely used by WASSCE and GES. Reduction and enlargement of maps. Today's topic is reduction of maps. Map reduction. So someone will ask, what is reduction of map or map reduction? Simply, map reduction is for making maps smaller. Making map smaller. Let's go ahead and solve questions so you understand what I'm saying. So let's take this. This is my topo sheet, and you can see from here that it's a WASSCE question for secondary senior high school, July 2004. So map A for question 1. So you can see here that we have a coordinate here. This is square. We have a coordinate here, A, B, C and D, A, B, D and C. This is it. And the question asks us to reduce this map by half of its size. So coordinate A here, coordinate B here, coordinate D here, coordinate C. I hope you all can see that. Alright then, let's put this on the board. Great. So let's assume the drawing on the map is this one. Coordinates A here, coordinates B here, C and D, right? Great. So what you are going to do is either get a thread or a ruler. So you rule from coordinates A and B. Remember we are reducing maps. There was a scale here. 1:50,000. I hope you all can see the scale. So don't forget the scale. When you are reducing maps, always remember the scale. The scale is 1:50,000 units. So now we get our ruler here, measure coordinates A, B. For the time being, I don't have a ruler here. So let's assume that when I measure coordinates A, B, the value is 6 centimeters. Let's assume that when I measure the weight, which is coordinates B, C here, the value here it is 8 centimeters. Now, we are reducing maps. So as I told you, reduction of maps simply means making the map smaller. So we need to make this map smaller. The question is asking us of half of these coordinates or this map here. This is the question is asking us to what? Reduce this to half of its original size. The value we are going to use here is divided by what? 2. Now, let me solve so you can see what I'm doing. Now let's find the coordinates, the new reduction value here for coordinates A and B. The new reduction value here for coordinates A and B will be equal to 6 here over 2. Since using it by half, so half of 6, right? Here is what? 20 centimeters. Now we need to also find the coordinate B and C, which is the breadth. Coordinate B and C, half of C, half of 8. Half of 8 is 8 over 2. The answer here is going to get 4 centimeters. Now we have what the reduction value for this coordinate A, B, C, and D. Now we need to use this to draw the reduced map of this. I hope you all get me. Nice. So in case we need to draw this, let's assume I have a ruler here and I measured here to here being what? 3 centimeters. Which is coordinates A and B. Coordinates A and B. And then we measured here to here to be 4 centimeters. Which is coordinates what? C and D. So this is what the reduced map. This is the reduced map for this block over here. And as students, don't forget the scale. The scale here we have here is what? 1:50,000. Remember that anytime you are doing reduction of map, and then the question asks you to find half of what? The value, we multiply what? The scale by 2. So here we have the scale here 1:2 bracket open 50,000, which will give us 1:100,000. Yes, like this. It is easy and simple. And remember that the scale always won't be divided by 2. When the question asks you to find 1/3 of the original size, you are going to multiply the scale by 3. It goes in that order. Thank you all for joining me today on the Lost Workspace, and I hope you learned something because I did. Great. Next time we meet again, I'm going to teach you enlargement of map or map enlargement. Thank you all. Stay safe, and I'll see you again. Bye bye.